Right, welcome to Chapter 18, Water in the Atmosphere. We have three sections. 18.1, Humidity and Condensation, which is what this video entails. 18.2 and 18.3 will precede. Here we go. Again, if you have not gotten your vocabulary listed in your lab notebook, please do so at this point. Go ahead and pause the video, get that in there. Then come on back and we'll start with the objectives. First objective, describe the three states of matter in which water vapor can exist in the atmosphere. Second objective, explain how water temperature affects the amount of water vapor air can contain. Next, analyze how condensation occurs in the atmosphere. Water exists in the atmosphere as a solid, ice, snow, hail, and frost, as a liquid in the form of clouds, rain, and dew, and as a gas, invisible as water vapor. What I'd like to do is talk about how heat is absorbed and radiated. This takes the lab that we did in 17 and puts it to the humidity and condensation concepts. So any blue arrow is when heat is released or radiated. Any red arrow is when heat is absorbed. So let's walk through these processes. First, condensation. That's going from a gas to a liquid, water vapor to a liquid water. Then we have freezing. It's going from a liquid to a solid. Deposition is when heat is released from a gas all the way to a solid. Now, melting is from a solid to a liquid. Evaporation, liquid to water vapor. Do you know what it takes for, or what it's called when goes to a solid to a gas? Sublimation. Nice job. That's when heat is absorbed. Specific humidity is the actual amount of water vapor in the air at a given time and place. When air is saturated, it means there is so much water vapor in the air that the rate of condensation equals a rate of evaporation. The amount of water vapor present in saturated air depends on the temperature of air. The warmer the air, the more water vapor it can contain, and the amount of water vapor roughly doubles every 11 degrees. For example, the particles in air, the warmer it is, the more they move. The more they move, the more they spread out and expand and get the distance between those particles increase. Well, that distance in between those particles, water vapor can fit inside, or different atoms and different molecules of water vapor can fit inside those spaces. When the air is warmer, there's more space for those water vapor molecules to fit. How near the air is to the maximum capacity for holding water vapor is called its relative humidity. Now, in this diagram, this walks us through how to calculate relative humidity. Now, relative humidity is a specific humidity ratio divided by a maximum capacity multiplied by 100%. So this ratio of specific humidity and maximum capacity is what we're going to be using to find the percent of relative humidity. Now, several different experiments relating to the same exact concept have been established to create a table, and we'll talk about that table here in a little bit. Now, if the air holds 11 grams per kilogram of water vapor, it can contain at most 22 grams per kilogram. Then it holds half of the water vapor it can contain. Thus, its relative humidity is at 50%, as you can see from the scale on to the left. Now, if relative humidity of the air is 25% and the temperature rises while the amount of water vapor in the air stays the same, what happens to the relative humidity? Think about what happens when the temperature rises and the air gets warmer. Think about what happens to the molecules. I'll give you a pause here real quick. Try to answer this to the best of your ability, and let's see what happens. It decreases because of the temperature of the air increases. The amount of water vapor in the air can hold increases. Because the relative humidity is the ratio of amount of water vapor in the air compared to the amount it can hold, increasing the amount of air it can hold without increasing the amount of water vapor in the air lowers the relative humidity. So it's like giving it more room with the same amount of water. So the relative humidity is lower. A psychrometer is an instrument used to measure humidity that consists of two thermometers. One is a dry bulb, one is a wet bulb. A relative humidity can be determined by using a psychrometer along with the dry bulb and wet bulb table. Something has been established through experiments based on the properties of water and air. Here is the example of that table. This is just part of the table. The relative humidity table is much more in depth when you go into a lab, or a meteorologist might use a more in-depth table, but this one is sufficient for what we'll do in class. To find relative humidity using a psychrometer in the table, first record both the dry bulb temperature and the wet bulb temperatures. We have a sling psychrometer in class. We also have a stationary psychrometer in class, so you could practice this in class as well. Now next, you determine the difference between the two temperatures, and then from the table you find the relative humidity where the dry bulb reading and the difference between the two intersect. Let's try it. Okay, let's say the dry bulb temperature is 16 degrees, and the difference between the two is 6 degrees. What's the relative humidity? Give you a chance to try it out. 46%. Very good. Why don't you take a dry bulb temperature and a difference, find out where they intersect, and practice this a couple times. Now on a warm summer day, the relative humidity is about 60%. Let's say that night the temperature does not drop very much at all. Predict if you'll find dew on car windshields the next morning and explain. Now probably not. Now if the temperature doesn't drop very much, the air probably will not reach full saturation, so dew would not form, and hence will not reach its dew point. Dew is when water goes from a gas into a liquid form. Now the temperature at which saturation occurs and condensation begins is called its dew point. Here's an example of dew on a spider web. The beads of dew on the spider web form from droplets of condensation water vapor. Dew point is the measure of the amount of water vapor in the air. The more water vapor the air contains, the less the air has to cool in order for condensation to start, so the higher the dew point. Now keep in mind that humidity is the measure of water vapor in the air. Warmer air can contain more water vapor, while cooler air can contain less, because those molecules are closer together in cooler air. They have less space in between those molecules of air. Now fog and clouds form when air is cooled to its dew point and water in the air condenses on condensation nuclei. Dew or frost forms if air cools to the dew point upon contact with cold ground and the water vapor condenses directly on the ground. If the temperature is above 0 degrees Celsius, it will form dew. If it's below that 0 degrees Celsius mark, it will form frost. Now two conditions need to be present for condensation. Number one is there must be material for water vapor to condense onto. Number two, air must cool to or below its dew point. Now condensation nuclei are usually tiny particles such as salt, sulfate particles, or nitrate particles. Here's a diagram of a microscopic picture of some condensation nuclei. You can see the soot in one of them, and down lower is a smaller amount of soot on another water molecule. Now a cubic centimeter of air, very small amount of air, can contain as many as 10,000 condensation nuclei. It can come from soot from fires, soil particles from wind, ejected volcanic particles, salt from seawater spray, and other industrial emissions. Now condensation occurs most readily on nuclei that are fairly large or likely to absorb water. Now we have tried to produce rain, artificially make rain, and we use what's called silver iodide. These are small particles usually drop from a plane into the atmosphere and hopefully develops condensation or fog or clouds. And not fog, it would be considered forming clouds. Fog is interacting with the warmer surface. That's it for 18.1. Please try the review section questions 1 through 6 as practice and just to check your understanding. If you have any questions, please let me know.